Hi everyone. So in this video, my plan is to talk about a little bit about the basics of the different things in metrics. And as many of you already know, that metrics has different kinds of operation systems. Like the properties in matrix is not like always as same as normal algebra. So there is some variation, there is some difference here, and all these things makes matrix to some extent some unique, little bit unique, and that's why we say matrix algebra, which is kind of a little bit different from normal algebra. Anyway, what is matrix? First of all, matrix is some rectangular array of numbers, some arrangement of numbers, rectangular array of numbers. Let's say we write some number here, some number here, some number here. We can write different numbers, and if we represent the numbers by all these things, then this is actually some representation of different numbers here. Why this representation is important is we may have different types of thing here. For example, this may represent some number of men. This may represent some male, let's say male people, some female people, some children here. Let's say this line represents something like who likes the number of people who likes fast food, who likes vegetables, and who likes, let's say, beef or something meat. Do you understand that thing? So all these numbers will represent the same thing, all this number will represent the same thing, all this number will represent the same thing. And this row will be the amount of male. This one is male, this one is male, this one is also male. Who likes the fast food, who likes the vegetable, who likes, let's say, meat. You see the amount of male who likes fast food, amount of male who likes this, amount of male who likes this, and female who likes this, female who likes this, female who likes this, children who like this, this kind of. So you see, basically in this arrangement we can actually represent something, represent some numbers, and a whole lot of information we can actually write within this. Now if you look at some matrix, let's say 1 2 3 4 5 6 2 1 0, something, whatever it is. So this thing is called the row. They are the row. These lines are row. This is another row. This is another row. So they are row. And from here, these are called column. Okay. This is row. This is column. And suppose a matrix. If I write 1 2 3 4 5 6, this matrix will be called. This is how many row here? There is 2 rows, so this will be 2. How many column here? 1 2 3. So this is 2 by 3 matrix. Okay, and this is actually 3 by 3 matrix, because 3 by 3 matrix is this one. Okay, and if I write another matrix, let's say 1 2 3 2 5 6. So this is, you see, 1 2 3. So 3 row by 1 2 column. So this is a 3 by 2 matrix. Okay, and if a matrix, if somewhere you see 1 2 3 4, suppose this is a matrix, number of column 1 2, and number of row 1 2. So this is a 2 by 2 matrix, and this is called a square matrix. This one also is square matrix, because this is 3 by 3 matrix. This one also is square, because this is 3 by 3 matrix. So if they have same number of column and same number of rows, this is called a square matrix. Alright, and there is another type of matrix which is called identity matrix. If the elements here are like this is an identity matrix, because if you multiply them, you get just only 1. This is called I2, that means identity matrix of order 2. And if I write another matrix, which is identity matrix of order 3, 1 0 0 0 1 0 0 0 1, this is called identity matrix of order 3. this is actually a 3 by 3 matrix, so that is why it is called I3. And I4 will be like 1 0 0 0 1 0 1 0 0 0 0 1 0, then 0 0 0 1. This is actually I4. Okay, this is the identity of matrix, identity matrix of order 4. So this identity matrix is basically just, it has the properties exactly like 1, because if you multiply them, you just if you take the determinant of it, then you get 1. What is determinant? Let me show you that first. So determinant of a matrix is the, let's say you have a matrix 2 3 1 5. So determinant of this matrix, let's say A equal to this. Determinant of this matrix is determinant of this matrix will be 2 into 5 minus 3 into this corner multiply, then minus this corner. So 10 minus 3, 7. 7 is the determinant of this matrix. Okay. Now there is one other thing which is called inverse of matrix. Okay. Let's say we have this matrix. How to find out the inverse? First of all, there are some matrices where you cannot find inverse. There are some matrices where you can find inverse. Let me show you them both. There are some matrices where you can find inverse. There are some matrices where there is no inverse. Say for example, if I write here 2 4, then if I write here 6 3. So this is a matrix, and say this is matrix B equals to this. What will be the, if you see this, then if you want to find the inverse of these two matrices, then you will see in one case inverse is possible, in another case inverse is not possible. First, let me show you how to find the inverse. I mean the theory for inverse. And theory for inverse is this. Let's say you have a matrix. You have a matrix P equals to A, B, C, D. Then inverse matrix, that means P inverse 1 will be 1 divided by AD minus BC. Then A and D will interchange the position. D will come here, A will go there. Then B and C will get, their sign will be reverse, their sign will change. So A and D will change the positions, B and C will have a minus sign with them, and this will be AD minus BC, AD minus BC. Okay, this is the rules for finding the inverse. So let's try to find out the inverse of this. So this will be 10 minus 3. Okay, 10 minus 3. Then they will change the position. So 5 divided by 5, 2 minus 3 minus 1. This is 1 by 7. 5 minus 3 minus 1, 2. Then if you multiply, it becomes 5 by 7 minus 3 by 7 minus 1 by 7, 2 by 7. Okay. And if we try to find out the inverse of this, what happens here is 1 divided by 2 into 6, 2 into 6 equals to 12, minus 3, 3 into 4 equals to 12, 2, 4, 4. We have to change their position, so 6 will come here, 2 will go there, 4 will go there, minus will come here. Now the problem here is, we get a 0 here, so 6 minus 4 minus 3, 2. And this is actually undefined. This value 1 divided by 0 is undefined, so this is undefined. We cannot find the inverse in this case. So if we cannot find the inverse, this kind of matrix is called singular matrix. This is a singular matrix. If we cannot find the inverse, this is called singular matrix. And if we can find the inverse, then they are called non-singular matrix. And this is the theory for finding the inverse. This is how to find the inverse matrix. Okay, this is the formula for finding inverse. All right. Now this actually explains a lot of things about finding the inverse and singular, non-singular, and what is the basics of matrix. If you want, I can actually, I mean, this is kind of, alright, I think this is enough for this video. We can make another video for other topics, for finding the other things for other topics. Okay, alright. I think this is good enough because we have more topics there to cover.